Before jumping into the description of each one of the statistical methods that we use for feature selection, I want to highlight some of the characteristics of these methods so you can decide which method you can use based on the model you're going to train and the characteristics of your variables. The statistical methods that have been used in the context of machine learning to select features are ANOVA, correlation, chi-square, and the mutual information. So when can we use each of these methods? It depends on the characteristics of the variables and the target. So if our features are categorical and the target is categorical, so we are in the context of classification, we can examine the importance of these features utilizing chi-square. Chi-square is a test that is designed to measure association between two categorical variables. Now, if the target is categorical and the features are continuous, then we need to use ANOVA, because ANOVA is a method that is able to compare the distributions of features across the different categories of the target. Now, if both the numerical features and the target are continuous, then we examine the feature relevance by using correlation. So what if we have categorical features and a continuous target? Well, in that case, we can use the mutual information. And in fact, the mutual information is a method that we can use for all types of variables and targets. So what if my dataset contains both numerical and categorical features? Which test can I use? Well, the test that is designed to work with categorical and numerical variables alike is the mutual information. Although the calculation of the mutual information, as we will see later, differs if our variables are continuous or discrete, so the value of the mutual information might not be directly comparable, but is the closest match that we have to select features based on a statistical test. Now, if you have categorical and numerical features and you encoded your categorical features already and then want to apply any of the other statistical tests, most likely the Python implementation that you use will work and will return a value of importance. It doesn't mean that we can trust those results, because these statistical tests have been designed to work in very specific scenarios. So if our data does not fulfill the criteria necessary for the test, then the results that we can derive from these tests are not reliable. So be careful here. The fact that you can implement it in Python doesn't really mean that the value that you get is a value that you can trust. Now, finally, I want to say a few words about the types of relationships that these tests evaluate. ANOVA is a linear model, so it will determine linear associations. So the value of importance that we get for a feature is going to measure the linear relationship that it has with the target. So using ANOVA to select features is a method that is used if we are creating linear models. And the same is true for correlation utilizing the Pearson correlation coefficient. The Pearson correlation coefficient measures linear association. So if we're using this test to select features, those features are useful for linear models. Now, features that are useful for linear models will probably also work with nonlinear models, like decision tree-based models, but not the other way around. Now, other types of correlation, for example, using Spearman or Kendall, will measure monotonic associations. So they can be useful for linear models to some degree. And finally, the mutual information and chi-square measure any type of association. So if you suspect that your features are not linearly or monotonically associated with the target, and you still want to be able to select important features accurately, then you're better off using the mutual information if you have numerical and categorical variables, or chi-square if your variables are categorical. So with this in mind, we will now move on to describe each one of these methods and how to implement them in Python. See you there.